Hello everyone. Today we'll be looking at some quick solutions to the chemistry section of All India AIATS Test Series JEE Main 2019 Test 8 Code A and B. So let's start with the first question. Question number 31. The total number of correct statements among the following is. So if you look at the statements which are given to us, the first statement says LiHCO3 does not exist in the solid state. This is the correct statement, students. This is the point of difference between lithium and the other alkali metals. If you look at the second statement now, silicones are water resistant in nature. So this statement is also correct. It is one of the important properties of silicones. If you look at the third statement now, presence of MnO2 inhibits the decomposition of H2O2. So this statement, students, is incorrect. MnO2 does not inhibit the decomposition. It in fact catalyzes. So in presence of MnO2, the decomposition of H2O2 is catalyzed. It's accelerated. So the third statement is incorrect. If you look at the fourth statement now, XiOF4 is square pyramid and the lone pair is trans with respect to oxygen. So if you look at the structure of XiOF4, we can first probably draw the Lewis dot structure. So it is going to have one lone pair left. So we have sp3d2 hybridization. So the lone pair has to be trans with respect to the oxygen. So we can see that the fourth statement is also correct. If you look at the fifth statement now, oxygen has most negative electron gain enthalpy among the group 16 elements. This statement, students, is incorrect. It has the least negative. If you look at the sixth statement now, LiH is most stable among the alkali metal hydrides. So this statement is correct because of similar sizes. So this statement is correct, students. So the examiner seems to be interested in the total number of correct statements. So we can see that 4 of these statements are correct and 2 are incorrect. So we have to mark option 1 as the correct answer to this question. Let us look at the next question. Question number 32. Consider the following molecule and select out that molecule which is the strongest base. So the examiner seems to be interested in the basic strength of these structures which are given to us. So if we look at the structures which are given to us and if we try to draw the conjugate acids, we're going to have these structures. So in the first case, we'll have this structure. Now we can see that this structure will be resonance stabilized because of the lone pairs of adjacent nitrogens. So both these nitrogens are going to help stabilize the plus charge which is present on the nitrogen. So this is quite stable structure. It will be quite decently basic. If you look at the second structure now, in the second structure we're going to have the structure. Here no resonance can take place. So this is not very stable structure and the corresponding base will not be very much basic. If you look at the third structure now, in the third structure, the functional group present is amide. The lone pairs of nitrogen are already delocalized. So it will be not very basic. And if you look at the fourth option now, in the fourth option, also there is an electron deficient carbon which is present. So the lone pairs of nitrogen will also be not very much available for attack as they will be stabilizing this carbocation present. So if you look at the structures which are given to us, we can see that the conjugate acid of the first structure is very stable because of resonance stabilization, and hence the base will be the most basic among all these given structures. So we have to mark option 1 as the correct answer to question number 32. Let us look at the next question. Question number 33. Consider the following reaction in which reductive ozonolysis takes place and then the reaction product X is heated in presence of dilute NaOH as shown below. Students, in the first step, the examiner is interested in the reductive ozonolysis, and in the second step, the examiner seems to be interested in the aldol condensation. So if you look at the product X, so this ozonolysis is going to break this bond, the double bond, and convert it into a dicarbonyl compound. So we're going to have the formation of this compound as X. Now when this is allowed to react with dilute OH minus in the presence of heat and HCl, we're going to have the generation of a carbon ion from the alpha carbon. So the carbon ion will be generated here as the attack from here will lead to the formation of a 6-membered ring. So it will go and attack the carbonyl carbon and the alkoxide will be generated here. So this will lead to the formation of this intermediate, and now when it is heated in the presence of HCl, it will undergo dehydration to form an alpha beta unsaturated carbonyl compound. So this is the final product Y which is formed. Now if you look at the options, the examiner seems to be interested in the statements which is not correct. So if you look at the first option, X has two chiral centers but it is meso. So we have the structure of X. It is correct that X has two chiral centers, but the compound will not be meso as there is no plane of symmetry or there is no center of symmetry. So the first statement is incorrect. If you look at the second statement, which says that Y has two 6-membered rings, this is also correct, student. We can see that Y has two 6-membered rings. If you look at the third statement now, Y is an alpha beta unsaturated ketone. So this is also correct, students. The end product of aldol condensation is an alpha beta unsaturated carbonyl compound, and we have a ketone in this case. If you look at the fourth statement now, for the formation of Y, dehydration occurs. This is also correct, students. In the formation of Y, there is a loss of water molecule from the alpha beta position. So if you look at the options which are given to us, we can see that the first statement is incorrect and we have to select that as the correct answer to this question. Let us look at the next question, question number 34. Consider the following given homogeneous reaction. So we have 2R converting into A, both are in the gaseous phase. So it is mentioned to us that the degree of dissociation of R at equilibrium is 1/3 and 2/3 at equilibrium pressure of P1 and P2 respectively. So we have to comment on the ratio of P1 is to P2. So we have to assume that the temperature remains constant during the course of the reaction. So if we try and solve the equilibrium which is given to us, so we have 2R converting into A. So let's assume that the initial pressure of R was P0. So we have P0 1 minus alpha giving us P0 alpha by 2. So the total pressure can be written in terms of P0 and alpha as P0 into 1 minus alpha by 2. Now we can talk about the Kp of this reaction. The temperature given to us is constant, so the Kp will not change. So the Kp will come out to be equal to pressure of A upon pressure of R whole square. So if we simplify these pressure values, we have P0 alpha by 2 upon PR. PR is P0 square 1 minus alpha square. Now we can substitute the value of P0 in terms of Pt and alpha. So we have alpha by 2 upon P0 1 minus alpha square. And the value of P0 can be substituted as Pt upon 1 minus alpha by 2. So we have alpha by 2 1 minus alpha by 2 upon Pt 1 minus alpha whole square. Now the Kp value will not change because the temperature has to be assumed as constant during the reaction. So if we put the values of alpha 1 at P1 and alpha 2 at P2, we're going to have both the expressions as equal. So we have 1 by 6 into 1 minus 1 by 6 upon P1 into 4 by 9. And this shall be equal to 1 by 3 into 2 by 3 upon P2 into 1 by 9. So the RHS will give us a value of 2 by P2. And if you look at the LHS, it is going to give us a value of 5 by 16 P1. So if we solve for the ratio P1 by P2, we're going to have a value of 5 by 32, which is given correctly in the fourth option. Students, for this question, we have to mark option 4 as the correct answer. Let us look at the next question now. Question number 35. The pH of an H2SO4 solution is equal to 3. If equal volume of 0.3 molar NaCl solution is added to it, then the pH of the solution will be. Students, NaCl is a neutral salt. It is not going to take part in hydrolysis. So the H plus ion concentration will just be halved as the volume is doubled. So initially it was 10 to the power minus 3 as the pH given to us was equal to 3. Now the H plus ion concentration nu after dilution shall be equal to 10 to the power minus 3 upon 2. So if we talk about the pH now, so the pH will be equal to 3 plus log 2. The value of log 2 is approximately equal to 0.3. So we have a value of 3.3. So students, for this question, we have to mark answer as 1. Let us look at the next question.